This video is a continuation from example 4, where we, in example 4, looked at an angle of elevation. In this question, we are going to look at an angle of depression. A yacht is noticed by a lighthouse keeper to be 750 metres from the base of the lighthouse. The angle of depression to the yacht, that is from the top of the lighthouse, is measured to be 2 degrees. Assuming the lighthouse sits on the edge of a 17-metre cliff, how tall is the lighthouse? The most important thing I believe that we need to do with this question, just like the angle of elevation question in example 4, we need to come up with an illustration. And I've created this illustration with the information provided in the question. What we have is a lighthouse resting atop a cliff, the cliff of which is 17 metres, meaning 17 metres above sea level. Here's our ocean, or this is our sea. The lighthouse we do not know, there's not information provided as to how tall it is, and that's what the question is actually asking, so I've called it X. We are given this distance from the base of the lighthouse to the yacht to be 750 metres, and we are finally given this angle of depression. Before we go and start to discuss solving this problem, I would like to discuss angle or angles of depression with regards to this 2 degrees, because it's commonly done incorrectly by students. Before even coming up with this image, when reading this angle of depression is measured to be 2 degrees, a lot of students that I teach assume that the angle of depression refers to the angle from the vertical. So they think that this angle in here is the angle of depression. Now, that's not the case. The angle of depression is measured from the same point at which the angle of elevation is measured. Now, funnily enough, those students that get these or this particular angle of depression question wrong often get the angle of elevation question right, because instinctively you think an angle of elevation is measured from the horizontal, which it is, just like that. So instinctively students will put this as the angle of elevation, which is absolutely correct because it's measured from the horizontal. Like the angle of elevation, the angle of depression is also measured from the horizontal, like that. So this angle that my pencil is making represents my angle of depression, which is why the 2 belongs there and not in here. It doesn't mean that we cannot figure out this angle in here. It is more or less as simple as recognizing that vertical to horizontal is separated by 90 degrees, which is why I've put this symbol here to represent a right angle. Therefore, this angle is going to be 90 degrees subtract the 2. Now 90 take 2 is 88. And once I've got that angle, I can simply forget that if I want. I don't have to work with the 2 anymore, because there's my triangle, and this is the angle in the triangle that I'm interested in. So that step is really important. Now we're there, we also note that having a lighthouse on top of a cliff, assuming that they are both vertical, and most lighthouses are built straight, God forbid they're not, they also, we're going to then assume that this ocean is horizontal, and generally you hope also it is, which is what creates our right angle here, being another 90 degree. Now we've got our right angle triangle, we can recognise that either Pythagoras or trigonometry is going to be something that we can utilise, and because we have an angle, we're going to be using trig. So the hypotenuse exists opposite the right angle, which is why I've labelled this H. The opposite side exists opposite the angle, which is the 88 degrees, thus the opposite side O, and our adjacent side is going to be this entire side, being the sum of the unknown X and 17, which I've simply called A. I could have called it X. Well, I guess technically I can't really call it X because I've called this side here X. And we know that these 2 here are not going to be the same. I've called it A because it's the adjacent side. I could have called it K, I could have called it B, C, D, anything really, but A is A for adjacent, so I've left it as A. Now we note that we've got information for an opposite, and we've also got some information regarding our adjacent. So what we are going to do is substitute, we're going to express our trigonometric function that utilises the opposite and adjacent side, which is our tangent ratio. Tan theta equals opposite divided by adjacent. And then we are going to substitute into the values that we know in the illustration. Theta being 88, the opposite side is 750 or 750 metres, divided by our unknown A. Now we're going to be finding this X because that's what the question's asking. It's asking how tall is the lighthouse, but in order to determine this, we need A. Now you will probably agree that if I had A, I could figure out X, because X is simply A subtract 17 being the height of the cliff, leaving the height here. So that is why we're going to look for this value first. Rearranging to solve for A, moving A to the other side, we multiply, and getting it by itself, we need to move this tan 88 to the other side, which we will need to divide because we've got to multiply on this side, or to divide this side by tan 88, we will get essentially rid of the tan 88, but if we divide this by tan 88, we also need to divide this by tan 88, which is why we get this. So we've now moved the tan 88 to the other side, leaving our A by itself, and on the right hand side we've got 750 now divided by tan 88, and in a calculator we get the value for A being the adjacent side, which is the sum of the cliff and the lighthouse. I've stated that the height of the lighthouse, X, our value X, is going to be equal to the value of A, which we've just calculated, subtract the value of the cliff, substituting in for A. As I said, the value we just calculated, subtract 17, will yield 9.19 metres. Therefore, the height of the lighthouse is 9.19 metres tall.